Howdy, welcome to lesson 4 on space teams. Today we're talking about putting a satellite in orbit around the Earth, or any planet for that matter, but our example is around the Earth. This one is a pretty short one, just adding some more things to the JSON file. Not dealing with Python yet, but we'll get there in the future videos pretty soon. So yeah, let's get to it. Okay, you're going to come into space teams, go to sim, user made sims, and I named it Satellite Orbiter, so whatever you named it. Again, it should be in that folder that we talked about in one of the previous videos on where you put all your code. Make sure it's in there and it'll show up in user made sims when you check this. You can also search for the name up here if you're having trouble finding it. Press confirm and let it load. Okay, once you're in, press spectator. I'm doing the reason it's just spectator is because that's the only pawn we put in is the flying spectator. Start sim. Okay, so once you're loaded in the sim, yeah, that's pretty complex design that we got here, but you should see a satellite orbiting Earth. Yeah, so I'll show y'all how to code this. So you can do it for yourself. Okay, so we're going to go through the JSON file that we set up to make that orbit that we just saw. There's not too much to add that you don't already know from the last video. It's similar format, but just some new systems and entities that we're using. The main thing is systems and how we apply them to those entities. So I'll go through it, but not every line since you all know more now. Meta is the same. Different title description, doesn't matter, that's up to you. That's for your use. Doesn't affect the sim at all. Include sims is different. We have Earth, Moon, Sun instead of, I believe we had moon-centered solar system last time. And the reason for this, the biggest difference between most of these basic sims is what entity, meaning planet, in this case, what planet is more the center of your sim. And this one is more generic, so it makes having the Earth as actually the Earth is not our center of our sim exactly, but keeping it around the Earth as easier than around the Moon. If you wanted to do this around the Moon, you could use this basic sim. You could use the one that we used in the last video. That's up to you. On the wiki, there is all these different usable basic sims to use, so go look at that if you want to use any other ones. Okay, so system manager is different this time. We don't have as many systems, but some very important ones. Spicy, very important for this. We had it in the last one. Basically, Spicy is being used to gather data about the Earth and the orbit with JPL and NASA data on, the Earth is not just a perfect sphere, so this is getting realistic data on what an orbit on the Earth would look like based off of where on the Earth you're orbiting. The rigid body propagator is the new one here though, and this is very important for orbital mechanics because this is used to calculate the velocity of the object based off of the parameters of the object. So you can kind of think of Spicy as used for the surroundings of the object, and rigid body propagator propagating the parameters of the satellite itself, in this case, to calculate what velocity it needs to be going at to keep its orbit. It's not doing it by itself, but it's being used for that. Make sure active is true, of course. The reason we have type task flow task is because it's being used in this task flow, which I will explain in 2 seconds, but that's why this is, make sure that's what it's set to. These are just different parameters set, different parameters set on the rigid body propagator. So there's two things here that are important. You can see how sometimes you're referencing your parameter to Earth, and sometimes you're referencing your parameter to Earth inertial. And the big difference here is Earth is rotating, so its coordinate system actually rotates with it. Earth inertial acts as if the Earth wasn't rotating, so the Earth rotates around a stationary, it's moving around the sun, but stationary relative to the Earth, and it rotates around it. So you can, that's very important for orbital mechanics because you want a set coordinate system to use, and sometimes you don't. So I'm not going to go into why each of these are used for inertial frames or normal frames, but I will say that's the difference, and to set them to what it is here. So body references are just going to be Earth, inertial references, Earth inertial. Yeah, so just follow this. Rotating with frame, again, that's a similar thing. We're not rotating with the frame of the Earth, so put that to false. Yeah. The next one, spicy, active, true. Nothing really new here. Just copy that in. If this was an Earth, you would change the planet name. In this case, it's Earth. So here's the important thing here that's very different is task flows have something in it. In the last video we didn't have that, so that's really new here. And task flows are used to tell the system what systems you're running in what order and how frequent. So here we have a task flow we're calling orbital motion, active true of course, and this is a type dependency graph. A dependency graph, you could think of it as an if-then statement that is multiplied by a ton. So instead of just one if-then, it does something dependent on a ton of variables. So depending on all the variables that you put into the system, it will come out with an output that it does. And this dependency graph is being ran based off of two systems, spicy and rigid body propagator. Just talked about why those two systems are important for this. Spicy is giving you data on the planet, and rigid body propagator is giving you data on the velocity and parameters of your object itself in a nutshell. It's a little more complex than that, but yeah, so this dependency graph is taking data from these systems and using those systems to then create a velocity and a heading for your satellite. So the reason you have dependencies here is you want to run spicy before you want to run rigid body propagator while doing this task flow. And the reason for that is rigid body propagator is taking from all the variables and setting a velocity to your satellite. And to do that, the variables need to be correct where it is at that time. And that's what spicy is giving you, is correct data on its location relative to Earth. I mean, all the data you need on the satellite's location to do that. So every run through this system, as you know, the system's running multiple times. That's why you have a frequency here. You're going to run it through one time. You want spicy to run first, so you get real-time data on where you are, and then you want to run rigid body propagator after to then work with that data to make a correct velocity on your satellite. And yeah, so that's what is new in the systems manager area, mainly using rigid body propagator and spicy through a task flow. And again, a task flow is a flow of your systems, task flow, just flowing through your systems in an order that makes sense and works towards your orbital mechanics. Okay, so now we go to data manager, the easier side of this. You have sim entity again, some new different stuff in here, and just for this sim, copy it over. This is just new graphics frame stuff. It has to do with the included sim that you use. This is for that included sim. Yeah, so this is the sim entity you're going to want to set up, and just copy this over instead of the one we used last time. So now entities, spectator, this is a little different because as you saw in the example, the spectator is following our satellite. It's not just stationary, and I'll show you an example of how to do that. So, but first, named, type pawn, same thing. We have no systems on it. We're not doing anything with it, with the spectator, doing stuff with the entity. Blueprint path, again, same thing. All this is the same as before. Graphics frame, we referenced the Pion Drive tugboat. That is the name of the satellite. In this case, you can name it whatever you want. But we're setting the graphics frame of our spectator to be the satellite instead of Earth or something like that. So that's important for this sim. Here's some more gadgets. There's some new ones in here if you ever want to use them. Again, gadgets are just at the top of your screen. I'm not going to go through them, but some of these are set to true. The ones that are set to true you'll see on the top of your screen, and you can use them. You saw that in the last video, but I'm not going to go through all those. Not important for what we're doing. Yeah, so here's another really important. You see how graphics frame is set to reference of the satellite, and the resonance frame is set to the satellite. So you're referencing your resonance frame and graphics frame to the satellite so that your spectator follows it. Yeah, so rebase center is set to false. We're actually about to use rebase center, you'll see in a second, but for this one it's false. Collider false, all the same. Graphics are the same. It looks a little different. It's just written out different, but it's still location, rotation, velocity, all that stuff. So all the same. They're all set to what their initial values are. And then here's where you actually set your spectator to be following your satellite. Attached to entity, pretty self-explanatory, referencing the satellite, the name of the satellite, which is the same name. Make sure that has to be the same name as your entity, which is your satellite. So it's referencing that, and it's following it. No clip is basically just that your spectator's not going to bump into anything. So like usually if you're a spectator on the moon, you're not supposed to be able to go into a hill or something. Like it's supposed to work as an object. In this case, it just means no clip. It's not going to hit anything. It's just following your satellite. And then we move on to the satellite itself. Interesting name, but that's what we have it as. Systems, rigid body propagator. That is what we talked about in the systems at the top. That's basically setting the velocity to the satellite based off of all of the parameters set through that task flow that was up there. So that's why this is in here. Blueprint path. It's just one that we have in space teams already. And then, yeah, so here's where rebase center is being used. The reason rebase center is being used now is the satellite is the center of our sim. I mean, our spectators following it. There's never a point where we're centered around anything else. So this becomes the center of our sim, and that's why this is set to true. Everything else is pretty much the same. Resin frame, Earth inertial. Again, that's kind of what we were talking about before. This is important because you want the resonance frame of your orbital mechanics to be set to a coordinate system that is not rotating with Earth, so that you can just do your calculations based on where your object is, or where your satellite is in orbit, and it makes it a lot less complicated. So make sure that's Earth inertial. Yeah, everything else is kind of the same. Drag coefficient and drag area, that's used for, I mean, that's self-explanatory. Drag, if there's some atmosphere up where you're in orbit. So you could set that to whatever those are for your specific satellite if you're doing your own satellite. Again, same stuff that we talked about before. This is just, all this is doing is putting clouds in your sim. Just have that there. It looks better because it has the clouds, but it also does the real physics of clouds. So include that if you're going to do a orbital mechanics or anything around the Earth. So that's all this stuff. And then here is, you have to set up that Earth inertial that we use up here as a resonance frame, because it's not set in space teams like Earth is. So you can't just and here you could just reference Earth without having that later, but since Earth inertial is this special case, you have to create another entity down here, well, entity kind of, called Earth inertial, that is based off of the SPICY system, which makes sense if you think about it. SPICY is giving you data on the Earth and the solar system as a whole, So you want to use that to base in your Earth inertial calculations. This is the source path for the Earth inertial frame that Space Teams has set up for you. So this is another system that has been set up for you. You just have to reference it here, otherwise you can't reference it in the rest of your sim. That's basically what this is at the end. So just include it, and it should work if all that goes right. So yeah. Well, thanks for watching again. Hopefully you guys know how to put a satellite in orbit now. We'll move on to other JSON and really soon Python files that you guys can use to make your own systems and do your own things that are not already put in Space Teams. But yeah, if you guys want to do an orbit around other planets, just as we talked about in the video, this is a very specific example towards Earth, so there's some stuff in the JSON you will have to change towards a reference frame that uses the other planet. If there's anything you guys don't know in the video or that I mentioned that you want to look at, it will be in the link in the description in the wiki for the video. So just take a look at that as you're doing your own orbits, and that should help out. Yeah, see you next time.